Hello. Okay, everyone's entering. Looks like everyone's coming into the meeting. Okay. While everyone's entering, I'm going to switch to screen sharing. Okay. All right. Let me get the list of. Okay, looks like almost everyone's here. Something went wrong. Oh, okay. Um, Everybody hear me? Does everything seem okay? You see the desktop?
Yes.
Okay. Yeah, I think I clicked on something. Something. The screen went blank for me. Okay, I think everyone's here. Here's what we're going to talk about today. Okay. Um, First thing I want to talk about is the next programming assignment. I put it up there after class on Monday. So it didn't show up until after class on Monday. So today's a good day to talk a little bit about this programming assignment. And then after we talk about the programming assignment, we'll talk about this chapter 3. And you have a new reading assignment, chapter 4, which is a much longer chapter than chapter 3 was. Chapter 3 is actually pretty short. Chapter 4 is a lot longer. We'll probably spend more than one day on chapter 4. It's a real important idea, something called methods. Okay, so we'll probably be spending more than a day on chapter 4. Okay, and then also I want to point out that besides this homework assignment that we're going to talk about, which is for you to turn in and get a grade for, I'm pointing to you some homework assignments that are in one of the books. And these are homework assignments that I just want you to do for practice. So for example, this page has a bunch of the mixed up code problems. So go back. These are the problems where you have to rearrange the code in this box over here. You have to drag and drop from there to there to get things right. This page has a whole bunch of these problems. There's a total of 14 of them on this page. And I want you to do as many of them as you feel comfortable doing. If you know, do, I say here, do at least this 6, 10, 11, and 12. I think those are good ones. Do at least those. If they start looking real easy to you, don't bother to keep doing them. But if you find that you're still, if you think they're challenging, keep doing them until you start getting very comfortable with them. So do these 4, and if they seem real easy, then go on to these next little group of assignments, which are a little bit harder. Okay, this other page are more programming assignments, assignments to ask you to write the code. Instead of just rearranging lines of code, the assignments ask you to write your own code. This page has actually got a total of 17 little problems on it, okay? And over here, I suggest or ask you to do 3 of them, okay? They're a little bit harder, okay? Do those 3. If you really feel comfortable, if you really feel that you can do these things easily, that's good enough. If they're hard, do a few more. You need to get used to doing Java. And if you have questions about, now they give you answers on these pages. So they give you feedback and they give you answers when you're working on these. But if you have questions about any one of these, send me an email or arrange a Zoom meeting. But programming is something like you have to just keep doing it to learn it. Programming needs to be done. It's like learning a foreign language. If you don't speak in the foreign language, you'll never learn the foreign language. And another one's like math. If you don't do math homework problems, it's almost impossible to learn math without doing math homework problems. And it's impossible to learn a foreign language. Java is a little bit like both. It's a little bit like learning a language. It's a little bit like doing math. So you need to be doing practice problems. Okay, so that's one nice thing about this book is it's got lots of practice problems. It's got, like I say, it's got 14 on one page and 17 on another page. Okay, so they're good problems. These are the slightly easier ones, the one that asks you to rearrange lines of code. These are the slightly harder ones that ask you to write your own code or either make changes in the code they wrote, or you have to write your own code. Some you just have to write your own. See, these are just comments. So you have to write all the code that goes in here. Here you just have to you have to finish this code. You have to put in things to finish it. Some you have to find the errors in the code. Okay, so do those as practice problems. Okay, so I link to the pages that have the problems on them, and I tell you which ones I think you should at least do. Okay, now close those. Now then there's the homework for grade. Yeah, that's the homework that's on this page here. Okay, so you go to the homework assignment page. Oops. Okay, and homework assignment 1 was due on Monday. And this is homework assignment 2. It's due a week from today. We don't have class on Monday. Monday is Labor Day, so there won't be a class on. We won't meet on Monday. Okay, so there's no school on Monday at all on campus either, or any of the class meetings. Okay, so here's the page. Every homework assignment has a page that describes it, and it comes with a zip file. Okay, so click on the zip file, download the zip file. I'm downloading it to my desktop. So there it is on my desktop. I can unzip it. Remember, don't just double click on the zip file and work with this. That won't work. You'll get really strange error messages. Don't work in a zip file. Whenever you download a zip file, just get in the habit of immediately unzipping it. Probably a good idea to just delete the zip file itself so you don't get confused by it, and then just start working on the homework in this folder. Okay, all right, and here's what this here's what the assignment is. In this folder is a program called Homework Too Long that draws this picture here that you can see on the right. Okay, so if Homework Too Long draws this picture. Let me open it in Dr. Java and show you. Okay, so I got Dr. Java open. Here's the long version of Homework 2. See, it prints the picture just by saying print the first line, print the second line, print the third line. So if you compile and run it, you get that picture down here. Okay, so there's that picture. Okay, so this is the long way to print that picture. Okay, your assignment is to write a shorter program that draws the same picture. And the way you're supposed to do it is by using variables to give names to all the parts of this picture that are redundant. Like, see this piece here, it keeps appearing all over the place. It's there, 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 there. So it would save a lot of space to do something like create a variable, a string variable, set it equal to what's in here. Okay. And then you could do something like over here, you can replace this by S, then plus the rest, right? The program's shorter already. And then you could do here, well, this guy here is also an S, okay? But I have to close that space, that string of spaces. So that string of spaces ended over here, and then I add on the, okay, notice how the program got a lot shorter. That line just became shorter, okay? But then this string of spaces here, it appears in lots of places. That string of spaces is in here and in here, okay? So I might say, I'll create another variable. String t equal, there's my spaces, okay? And then this guy can be t, right? Right? And now this line here could become, oops. Okay. This line here is S plus T plus S. Actually, I can check if I compile this, run it. I can check that I haven't done anything wrong. The output's exactly like what it was before. The output hasn't changed, but the program is becoming shorter. The program is becoming shorter. Now, notice I can do that here, and I can do that here, and I can do that here. But then you might notice that this s plus t plus s keeps appearing over and over again. So you can come up with another variable that represents s plus t plus s. So the idea is that we're gonna, like we talked about last week in class, when we talked about this example, let me go back to the website, the web course. Last week we did these examples of variables. And we did this idea that if you're gonna greet a bunch of people, hello there, Bob, hello there, Jane, hello there, Alice, you really wanna abstract the part that keeps getting repeated. So you abstract it in a string, and you call that, the string represents hello there, okay? And then you can say, hello there, Bob, hello there, Jane, hello there, Alice, real easily. And then if you want to change the greeting, you can change it in one place instead of changing it over and over again. If you wanted to translate it into another language, you translate it once instead of translating it over and over again. So we call this variable abstraction, using a variable to represent something that's appearing over and over again in a program. And we have that in spades over here in this example. We have all kinds of stuff that's appearing over and over again. So there's lots of opportunities for variable abstractions. And that's how you make this program shorter. You're supposed to make it shorter by finding things that keep appearing over and over again. There's something that appears over there too. So give a name to something that appears more than once, then use that name, whatever you want to call this, you can use that name for it there, and the name will be shorter than all those plus signs. Okay, and then even when you give names, like here, that can be named also, because that's going to appear, s plus t plus s is going to keep appearing over and over again. And then, okay, now let me back out of this. I'm going to undo the changes I made. This whole block here is the exact copy of this whole block here. So you can make the program almost half as long right away by just giving a name to this whole half and then reuse that name down here. So that's another example. So right away you can cut the program almost in half just by saying, well, we can give a name to all of this somehow and then reuse that name down here. Okay. Now, how do you know how? Now, I want you to make a shorter program. That's going to be what you turn in. That's just going to be this homework2.java. You're going to rewrite this program shorter and call it homework2.java. Okay. Now, right now, how long is this program? If you go here to Windows, you can right-click on that file, ask for the file's properties, and Windows tell you how many characters are in the file. Now, it uses the word bytes, not characters, but this file has 2,581 characters in it. Now, that's counting every character starting here at the beginning. There's 1 character, 2 characters, 3 characters, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Now, if I counted through this whole file, which I'm not going to do, but if I counted through this whole file till I got to the last character, I can count till I would count 2,581 characters. So Windows will do that for you. It'll count them for you. You're supposed to write a version that has less than 600 characters in it. So you'll be writing a version over here in homework2.java. Right now, that file is, it's got a little. Right now, that file's just got a bare bones program in it that doesn't do anything. So you have to complete this program, put your name up here, put your code down here. Right now, this file has only 93 characters in it. So right now, it's only got 93 characters. So you're going to add about 500 more characters to it, at most 500 more characters to it. So you should be able to do this with a file that's less than 600 characters long. Okay. So your job is to write that output. Oops, wrong tab. Your job is to write all that output using a lot less characters. Using your program should have only about 600 characters in it instead of having this 1,500 characters in it. Okay. And you do it by using variable names, look for anything in here that you can name, and then if you can give it a name, you can use the name, which is going to be shorter than the thing you're naming, and just look for redundancy and give names to the things that are redundant. If something repeats, give the repeated thing a name. So that's like when we saw that you gave this a name, which also gives this thing a name. Then you can give the spaces in between here a name. So we had S plus T plus S, but that appeared here, 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 here. So give a name to S plus T plus S. Make a variable whose value is these other variables. So use names to shorten things. Okay. Now, your program should still be formatted nicely. You're trying to make it shorter, but you should still be formatting it nicely. So you'll say string S equal, you know, and then you'll have another string. Okay, I'll call it T equal. Now your program should be nicely formatted as you're going along. Okay, so it should be a readable. You're not supposed to make things shorter by scrunching things. Now, I'll show you that what I mean in a minute. Your program should be nice and readable. Okay. Then there's a game that programmers like to play sometimes of trying to make a program as absolutely short as possible. Okay. So for example, if I go back to this program here, I can make it a little bit shorter by doing the following. Okay. The word public doesn't really have to be there. I don't really have to put my name in there. Java doesn't care if I put my name in there or not. Java doesn't care where I put that brace. Java doesn't care if I put those spaces there. Java doesn't care. Now, Java doesn't care, but people who read your programs care. But Java doesn't care if you have those spaces there. It doesn't care if you have those spaces there. It doesn't care if you have those. You can go through your program and just start making it shorter by doing things that make it unreadable. Okay. Now, let me show you. Java doesn't care that I'm doing all this. So far, I've got this top line being really unreadable, long kind of mess here. Java doesn't care. I can compile this, and it still runs fine. Okay, right? And I can even make this more unreadable. Like the space between that and that doesn't have to be there. I can abbreviate args to be A. Doesn't even have to be called args. You could call it anything you want. Okay, so I'm just making the program shorter. Java doesn't care. It's still okay, right? So for a second part of the problem of the program assignment, I want you to create a file called homework2short, in which you're supposed to try to make your program as short as possible. Try to make it as short, and I don't care if it's readable or not. Just try to make it's just a kind of a game. How short can you make the program and still make it compile and run and print the same output? For example, I have a program on my computer that prints the right output, and it's only got 220 characters in it. Okay. Now, here's this short one I put in here. I started it for you by shortening this as much as possible. So I took this one and shortened it as much as possible. So I got rid of the name, got rid of public. I got rid of the space after this here. I changed args to R. Okay, none of these spaces have to be there. You can't get rid of that space. You cannot get rid of that space, because if you do, then it becomes all one long word, and Java doesn't understand that. Okay, so, but this is the shortest program that will still compile and run, though it doesn't do anything. Okay, so I want you to take, when you've got your homework 2 written, go ahead and shorten it as much as possible. Get rid of all the spaces that don't have to be there. Make it unreadable, but then just see how short you can make it. Okay, now I've got mine down to 220 bytes. My short version is 220 bytes. And you might, if you might try to see how short you can get it. You might see that you can make this one shorter, which will make this one shorter. Okay, This one, you have to have less than 600 bytes, 600 characters. That's the assignment. I don't really care how short you make this one. It's just once you got this one, make it as short as you can to make this one, and you'll see how long it is. And you can definitely, if you try real hard, you can get this one down to around 220 bytes. It took me a while to do that. I had to think a lot about variables. I had to go back to the long one and look for lots of places where I could find variables that represented something. And by thinking real hard about anything that was redundant that could be named and then giving it a name and reusing the name, by doing that a lot, I was able to get my short one down to 220 bytes. Okay. It's not that hard to get the long one under 600 characters. Okay. It takes a little bit more work to get the long one to be around 400 characters. Okay. And then if you get the long one, if you get this medium one, if you get the medium one around 400 characters, then your short one will be around 200 characters. So it's not hard to get the medium one to be under 600 characters. And then with some effort, you could get the medium one to be around 400 characters. And then the short one should end up being around 200 characters. Okay. If your medium one's around, the assignment is for your medium one to be 600 characters. Your short one will probably be about 300 then. The short one will probably be about half of what the medium one is. Okay. Mostly what you're doing is you're getting rid of all these indentations. You're getting rid of all the indentations, which are there to make programs readable, but Java doesn't really care that they're there. So you can get rid of all the indentations. And then there's, in the homework assignment, I point out there's another little trick you can do. If you read the homework assignment, here's a trick you can do to make a program shorter. Suppose you have two strings. String A is cat, string B is dog. You can abbreviate that to one declaration. You can say string A is cat. Now, notice this one ends with a semicolon. Then you, instead of a semicolon there, you put a comma. Then you don't have to repeat the string again. So you can say A is cat, comma, B is dog, and you saved yourself typing that string word again. Okay? And then you can even take this and abbreviate it some more by getting rid of the unneeded spaces. That space doesn't have to be there. It should be there for properly formatted programs. A properly formatted program should put a space around the equal signs to make it easier to read. There should be a space after the comma to make it easier to read. But you don't have to have those spaces there. So this can be all run together to become this. And I could have also pointed out you could have deleted the indentation also. So the indentation, from Java's point of view, the indentation doesn't have to be there either. Okay, so use little tricks like that to shorten your medium length program to a super short program, just more for fun, just to see what you can do in Java. Programmers sometimes actually have contests sometimes where the competition is to write the absolute shortest program that prints a certain output. There actually are competitions like this. Okay, and there's all kinds of tricks for making Java programs shorter and shorter and shorter, mostly using variables. Okay, and then getting rid of all the unneeded spaces. Okay, so I give you the long one. You're supposed to write a medium length one that's less than 600 characters, and then get rid of all the spaces. Turn your medium one into a short one, and then see how short your short one can get. Okay. So that's your homework assignment. And it's really an assignment in practicing using variables. You're going to look at this output and just try to find everything in it that's appearing more than once, give it a name, and then reuse the name. That's the variable abstraction. And that's the idea of what we did last week in it's this idea over and over again. Instead of repeating hello there, hello there, hello there, give it a name, use the name. Here it wasn't to make things shorter. Here it was to make things easier to modify. If I want to change the greeting, I change it in just one place instead of having to change it in 3 places. If I want to translate the greeting to a different language, I translate it once instead of translating it over and over again. Here, the variable wasn't to make things shorter. it was to make things more convenient. That's usually what you do in programming. You use variables to make things more convenient. But in this homework assignment, I just turned things around a little bit. You're using variables to make the program shorter. Okay, anybody got any questions about the homework assignment? Due a week from today.
So this homework assignment wouldn't be including methods that we're going to learn today, right?
No, yeah, it just only use variables. Yeah.
Okay.
Only use, pardon me?
Okay, I was just.
Yeah, you're right. We're going to start talking about methods. Your third homework assignment will then be about. That's a good point. The methods will be in your third program assignment next week. This one just using variables. So the assignment is to only use what we're talking about using variables. Okay. Yeah. Okay. So name things. Try to find things you can name. Okay. What about other questions from the homework? Anybody got another question about this homework assignment? Again, you can ask questions anytime during the week, but anybody got a quick question that this comes to mind right away? Oh, you'll send back to me your version of the medium one and your version of the short one. So you'll be sending me 2 files. Okay. So you'll send back to me your version of homework 2 and your version of homework 2 short. You don't need to give me back homework 2 long. You won't be changing that. Yeah. And I wrote a little short demo to show you an example of what you can do to make things unreadable. Okay. So here's a Java program. One long line, kind of hard to read. That program is 142 bytes long. And if you run it, it amplifies itself. It actually is outputting 1,000 bytes. So a 142 byte program outputs 1,000 bytes by using lots of variable names. Okay. So it's just now, and the idea here is just see how you can kind of read that. So I've got a string A, which is 1, 2, 3, 4, 5, 6, 7, 8. Then that comma means I'm still declaring strings. So I'm declaring more strings. So there's a comma. Then I got a string called B, but B is 2 copies of A. Then I've got another string called C, and C is 2 copies of B. Then I got another string called D, and it's 2 copies of C, and I can kind of go along here and read. It's not real readable, but I can sort of read it. Then I see the semicolon says that there's the end of all my strings. See, that semicolon ends the statement. That's all one statement. So from here to the semicolon is one Java statement broken up into pieces by the commas. And then there's a print statement. Okay, and it prints the last string, which ends up having 1,000 characters in it. Okay, so this is what I mean by you can take a program and make it shorter and make it kind of unreadable. I can go back and make this a real Java program by lengthening it. If here's semi-readable. Java doesn't care that I'm doing any of this, but it would make it, from a human's point of view, it makes things a little bit more readable. Okay. If I was really doing this as a programmer, I would go ahead and do something like this to make it easier for someone to figure out what I'm doing. That I'm really defining a B, then a C, then a D, and an E, then an F. Okay. If I wanted to be readable by somebody, I would make it look like this. Okay. Yeah, that would, and then I have to. Okay, so yeah, from Java couldn't care less. That is the same thing. So that's the readable version, and there's the unreadable version. Java doesn't really care. Okay, so you can make things readable. Now, programmers care a lot. Unless you're in one of these competitions where the job is to make the program, or the challenge is to make the program as short as possible, you would never write code like this. Nobody accepts unreadable code, but it is something that programmers do for fun every once in a while. Just ask, well, how short can I make this program? Okay. All right. So you don't turn in, let's see. So you'll turn in the medium one and your short one. Okay. And I say the goal of the assignment is to have the medium one under 600. The short one's more for you. You can just, you can try to make your short one as short as possible. You can, I can tell you now, you can get it to be around 200 characters. Though that's a little bit, it takes a little bit work to get the short one down to close to 200 characters. But that gives you a sense of, you may, if you want to make this one shorter, you'd have to go back up here and think, what can you do in your medium one to make your medium one shorter so that your short one gets a little bit shorter. And the challenge is to go back to the original program and just really look hard for redundancies. Really look hard for things that are repeated. It's a good programming exercise. Finding repetitions in a program, we'll see as the semester goes along, that's something we do all the time. We're always trying to find things that are repeated in a program and get rid of the repetitions to what we say, abstract them. Okay, we don't want to type. There's actually a thing in programming. Oops. See if it shows up here. If you type DRY, see this? See, it comes up almost at the top. You Google DRY. And almost immediately you get this thing, don't repeat yourself. That's a programmer's idiom. They call it dry. When you're writing your programs should be dry. You're not supposed to repeat things. Okay? And it's an idea in programming. It's not an idea in English or in writing. It's an idea in programming that you shouldn't be repeating yourself. And if you look at this homework assignment, I'm sorry. If you look at this this thing, it's repeating itself constantly. It repeats that line, and it repeats that line, and it repeats that line. And so a programmer would look at this and say, boy, this is really bad. You're repeating yourself all over the place. And one of the ways you get rid of repeats is variables, but there'll be other ways. Methods are a way to get rid of repeats. For loops are a way to get rid of repeats. So we're going to learn lots of ways of getting rid of repeats. And variables is the first one. First thing you learn about how to avoid repetitions, don't repeat yourself, dry, is to use variable names. Okay? So we'll be seeing this over and over again as the course goes along. We're going to be learning to program is a lot about learning to say, this thing here and this thing here are repetitions. So what can I do to avoid the repetition? And we'll see why you want to avoid the repetition. Like, why do you not want to repeat yourself? So that'll come up as we go along. Why would you not want this? Why do you not want to repeat yourself? And then the tools you use to avoid repeating yourself are mostly variables, for loops, and methods. Okay. All right. So that's homework assignment 2. Okay, so do a week from today. We don't have class on Monday because it's going to be Labor Day. Okay.
I got a question about that. Do you want us to upload the screenshot of that too?
Oh, no. Screenshot was just for the first assignment.
Oh, okay.
Yeah, no more screenshots. Your programs will end up they won't fit in a screenshot. After the first homework assignment or 2, your programs won't even fit in a screenshot anymore. Like this one still would, but after a little while, your programs will get too long to fit in a screenshot. So yeah, the screenshot was just for the first programming assignment. Okay, screenshots are good if you have questions, if something, when you have a weird mistake on your computer, now you know how to take a screenshot. That's a good way to ask questions. Take a screenshot of the weird mistake on your computer. Screenshots are good for questions. When you have questions about your code, don't send me a screenshot. Send me the code. Sometimes people have questions about their code and they send me a screenshot of Dr. Java to ask a question about code. That's actually not a good way to ask questions about code. You should just send me your file. Send me your program. Attach it as an email or cut and paste your code into the email. You can just go ahead and you can copy and paste some code from your program into an email and ask questions about it. Don't send me a screenshot of code. Okay, that's usually not as helpful as sending me the code. But if you have an error message, or if something's kind of funny in your output doesn't look right, then you can send a screenshot of that. Screenshot of bad output, like why did my output look like this? Screenshots of error messages, why did I get this weird error messages? But if you have a question about code, you're better off sending the code. Either attach it to an email or cut and paste it into the email. Usually attaching it's the best. Just attach your homework, attach your file to an email and send it to me and say, I have a question, and then ask your question in the email and attach your program. So screenshots are great for asking questions, but questions about code, send the code. Okay, other questions about the homework, anything else? Oh, somebody asked in the chat. No, you don't need to put your name in the short one. That's why, yeah. See, the medium one definitely should have your name in it. The medium one's supposed to be nicely formatted. The short one, no. The short one, just start with this. Put your code in there. Yeah, you don't, to make it fair, that you're really making it as short as possible, you don't need to have your name in there. Otherwise, it wouldn't be really fair. So your short one doesn't have to have your name in it. Okay? Okay? The short one can really be as short as possible. Get rid of everything that doesn't have to be there. Okay. Other questions? Anybody else got another question? Okay. All right. So let me close Dr. Java real quick. I'm going to start over again. We want to now go to this chapter. We want to talk about what's in chapter 3 here. Now, remember, it's in 2 places. We're going to talk about the scanner class. It's in chapter 3 of this book, and more or less the same thing, but written a little bit differently. It's in section 1.4.6 of this book. So I think it's good for you to read both and compare them. They're both doing the scanner class. Okay, here's their example of the scanner class, and then here's their example of code for the scanner class. Okay, so I'm going to just write my own example. So maybe we'll go back to the example here, but I'm going to start off with just doing an example in Dr. Java. Dr. Java turns out to be a great tool for learning how the scanner class works. Dr. Java works a little bit better than the online version of Java here and the online version of Java here. So I'll show you what I mean in a minute. But Dr. Java does the scanner class very, very well. Better than, for example, the Java Visualizer. The Java Visualizer doesn't visualize the scanner class all that well. Okay, so I'm going to start up Dr. Java. I want to show you some examples. The goal of the scanner class is to get input from a user. There's actually kind of a nice picture in here. Here's your program. Your program wants to get input from somebody. Now, what they mean by input, something that somebody types at the keyboard. You want what they type on the keyboard to go into your program, so your program can output something depending on what it read. Okay. Now, this thing here, a program that reads someone's name and then says, hello, Fred, is their example right here. Okay, so like we say, okay, so this simple example here, this here is the Java program. The output we kind of know about already. The output is this thing here, system.out.print. What's new is going to be, how does the program get some input? How does the program get input? And to do that, you use something called a scanner. To use a scanner, you have to have a new kind of thing in a Java program. The first line of the Java program has to be something called an import statement. Well, later on, we can maybe say a little bit about what these import statements really are, but it's a little bit like this public static void main string args thingy. Right now, you just type it, okay? So the program starts with this thing that says, I'm telling Java that I want to use a scanner. So you import java.util.scanner. That has to be the first line of the program. So it has to be at the first line. Okay, you can't put that inside of the program. It has to be before the public class. Okay, so then your first line of your program has to be what we call creating a scanner object. You have to actually create a scanner. So we're going to be doing a lot of this as the semester goes along. But what I'm saying here is I'm creating a variable called scan. And the variable is pointing at a scanner object, which is tied to the keyboard. The system.in is the keyboard. Just like system.out is the output window, system.in is the keyboard. So input, this input is system.in, and this output is system.out. This input is the keyboard. This output is the window, the computer window. So it could be a little window down here. In the case of Dr. Java, system.out is this area down here. It's this thing called the console. This is system.out. Okay, right? So system.out is where programs send their output, and system.in, which is the keyboard, is where programs get their input. Later on, we'll see that system.in can be more than the keyboard. System.in could be a database. System.in could be an internet connection. System.in could be a file on your hard drive. We'll learn how to do all that later on. Okay. Right now, system.in is the keyboard, is what people type as the keyboard. But programs can get input from databases, files, internet connections. So we'll eventually learn a little bit about each of those. But for now, for a long time, for most of this course, system.in is just going to be what people type at the keyboard. Okay. So this is your way of saying that you want to read input from the keyboard using this variable called scan. And this variable can be given any name you want. Like I tend to call it scanner. Some people like to call it SCN. Some people like to call it input or in or input. For example, if we go back to this other book, see, here's where he's creating the scanner. He calls it in. So he's creating a thing and giving it a name. He gets to choose whatever name he wants to give that thing. He chose the name in here. This book chose the name scan here. Okay, so this is how you create the thing, and you can give it any name you want. So scan, scanner, in, input. You'll see people use all those names. Okay, now this program sends a message to the user saying, please enter your name. Okay, right? So the program prompt, we think this is a prompt. It tells user, I want you to type something back to me. So please enter your name. Then the program uses the scanner to get the next line of input from the user. So this is how it works. The scanner, which he called scan, we call this method which asks the scanner for the next line of input that the user typed. Okay, then we give the name to what the scanner gives back to us. The scanner is going to read from the keyboard and give us back a string. So, and we give that string a name. Okay, and then we print hello name. Okay, now when we run this program, because this thing's in a web page, it actually doesn't know how to read from the keyboard. So they have to fake it, and they pretend that this is the keyboard here. So in this web page, this is why it's actually not a little bit, not so great. In this web page, the actual scanner isn't connected to the keyboard. It's actually connected to this little box down here. Okay, so when it reads from the scanner, it reads what's in this box. So if I run this program, okay, see, please enter your name. Now here's where you pretend that somebody typed their name, but then the program really read not from what people typed, the program read from this box down here. So for example, if I change this, now I'll run the program again. Now it's going to pretend to read, it's going to read from what's in this box. It's pretending to read from a user who's typing at the keyboard, but it's in fact really reading from this box. Now it's going to read what's in the box. Okay, see, hello, Fred Jones. I mean, this is not great. So that's where if we switch to Dr. Java, in fact, I'll go ahead and take this. and I'm going to copy it, and I'm going to go to Dr. Java. And we'll see that it works a little bit better if I use it in Dr. Java. Okay, so here's that exact same program in Dr. Java. Now, if it's in Dr. Java, I have to save it to my hard drive and then compile it. So notice it's an untitled, it hasn't been saved, it's just untitled. So I'm going to save it. Dr. Java knows to change the name to what they called it here, name reader. I'm going to save it on my desktop. I was in the full homework too. Now I want to switch to the desktop. Save it. Okay. So I've saved it as this file. Okay. I saved it as this file name reader on my desktop. I'm going to compile it. Okay. Now Dr. Java really talks to your keyboard. Unlike this website where they had to fake it a little bit. It was kind of, I guess they just didn't really know how to get a web page to talk to the keyboard. Now, these people actually, and we'll go back here. Theirs works okay. Theirs works much better. This one works way better with the scanner. We'll go look at it in a minute, but still not as good as Dr. Java. So there's this one, their system is better than this system, but still not as good as Dr. Java. Okay. Now let's see how this works in Dr. Java. Okay, so I've compiled it. So I compiled it. Now I run it. Here is where Dr. Java is waiting for you to type input. Do you see this? It's above the little black bar, right? Zoom is kind of weird. Zoom puts a black bar where part of the Zoom interface is. This prompt is above the black bar, isn't it? Anybody tell me?
Yes.
Yes.
Yeah. Okay. Yeah. You see a black bar on the screen, right? Do you?
Yes.
Yeah.
That black bar is part of the Zoom interface, and it's I guess it hides from you my Zoom interface, but my Zoom interface shouldn't be blocking part of the screen. It's actually kind of weird. I don't know if there's a way for me to get rid of that black bar. Yeah. But okay, if what I'm talking about is ever underneath the black bar, let me know, because I don't see it. I didn't even know it was there until I looked at one of the videos, and then I realized Zoom's doing something weird here. Then I realized what Zoom was doing. It was showing part of the Zoom interface, and actually that black bar, that part of the Zoom interface isn't even on my screen. That black bar is a part of the Zoom interface that I don't even see. That's why it's really weird. I don't see that part of the Zoom interface on my screen, but the Zoom video still shows a black bar there. So it's very weird on their part. So I have no real way of knowing when something on the screen is under that black bar. So if I'm ever pointing at something and it happens to be at the bottom of the screen under that black bar, let me know so I can move the screen around. Okay. All right. Now, right now, this box here is this line of code waiting for the user to type something. Okay. So I'll type my name. Okay. I type my name. And it's still sitting there. The question is, how long is it going to sit there? Anybody want to guess how long it's going to sit there?
Until you hit enter.
Yeah, usually when programs are waiting for input, they wait until you hit enter. Okay, so yeah, the key is please enter your name. So right now it's waiting for me to hit the enter key. So I'm going to hit the enter key. You might hear it in the video. When I tap the enter key, then the line 9 of the program, what happened was I was blocked on line 9 of the program all that time. When I was down here, line 9 was waiting for the scanner to come back with a name. The scanner prompted me here with a box and waited for me to fill in the box. Okay, now let me run the program again. Well, I don't have to compile. I'm in such a habit of compile, run, but when you want to run a program again, you only have to hit the run button. You do not have to recompile the program. Okay. Now, I type my name. Then I decide, no, I don't want to use my real name. I want to use an alias. Okay. So I see, notice that I can make changes. See, I'm allowed to make changes. I can keep changing things until I decided I'm done, then I hit enter. Okay, that's why this thing blocks until you hit enter. What it's doing is it's letting you edit what you want to type. When you're finished typing what you think you really want to type, then you hit the enter key, and then this thing reads what it's when you hit enter that this thing reads what you typed and puts it in this variable here. Okay, so this variable doesn't get a value until you hit the enter down here. Okay, now so this is Dr. Java shows this in a much clearer way than what's showing you in this website. In this website, you don't see that this thing is what we say blocking until somebody hits enter. Here, the input's already been typed ahead of time, so this thing just reads what's in that box and then returns right away. So it's a little bit not accurate. Dr. Java shows it much nicer. Dr. Java shows you this box where there's the input. Okay, now let's see how theirs works over here. Here's another system. Okay, here's a program that, see, it imports scanner. They name the program Echo because what it's going to do is it's going to repeat whatever you type in. It's instead of asking people for a name, it's just going to say type. It's going to prompt the user saying type something. It's just going to read in whatever they typed and call it line. And then it's going to print out you said. It's just going to echo what the person typed in. And then it's going to do it again. It's going to ask them to type something else. It's going to read it in to the same variable line. And then it's going to print out what was in the line. Okay, so this one prompts 2 times. Okay, now let's run theirs and see how theirs works. Okay, see, now notice there's the prompt. There's the little blinking cursor is them waiting for you to type something. It's not quite as nice as the big box that Dr. Java shows you, but they give you this blinking cursor. So, okay, the blinking cursor is letting me change. Okay. And the blinking cursor is there until I hit enter. So like Dr. Java, it's waiting for me to hit the enter. When I hit the enter, right now this thing is stuck at line 10. See, line 10 is this first input. It's stuck at line 10, waiting for me to hit enter. When I hit enter, line 10 will get the value of what I typed in. Line 11 will print out something. Line 13 will print out another prompt, and then it's going to get stuck at line 14 waiting for new input. So watch that happen. I hit enter. Okay. I hit enter. Line 10 finished. Line 11 printed out what I typed. Line 13 typed this prompt, typed something else. And now I'm stuck at line 14. Okay. So I'm stuck at line 14 waiting for more input. Okay, so now I type a bunch of stuff, and it's gonna let me. It's the cursor is blinking, waiting for me to type enter. So it's gonna just it's just gonna sit there until I hit enter. When I hit enter, then everything I typed here will go into this variable here, and then get printed out.
So we don't need to make a new scanner class each time we ask for the user to input?
Yeah, no, you only make a scanner class one time. That's a real good point. You only create one scanner class. It's actually a mistake to create 2 scanner classes. If you do, things get all messy. Yeah, so it's real important. And the book actually forgets to point that out. That's actually a really good question, because it looks like you would say you would need a scanner for every input, and that's not the way it works. You create one scanner, you use it throughout your whole program. If you do create more than one scanner, sometimes weird things happen. Java doesn't like it when you have 2 scanners trying to read from one keyboard. So you only need to create one scanner. Usually people create at the beginning of their program and then just keep using it for input, okay? So one scanner, and you can see how it worked here. That one scanner was used here, and then it got used again here. Okay? And you can keep using it as many times as you want. Okay, now let's take this program and let's put this one in Dr. Java and see that it works. So let's see how this one looks when it's in Dr. Java. So I'll create a new file here. I'll put their version in Dr. Java. It will work almost the same in Dr. Java. Now I need to save it. Okay, it gave it the right name, Echo. It's on my desktop, so save it on my desktop. Okay, so there's their Echo program now as a file on my computer. I compile it. Okay, I got the Echo class. Oh, you notice that when you run these things on the internet, you never see the file. Where'd I go? One thing that's kind of interesting is you never see the file that this thing's actually sitting in. And you never see the class file that's created when you compile that. All that happens behind your back. It actually doesn't even happen on your computer. It happens on the computer that is running this website. Your program is actually compiled not on your computer, on their computer. And then the class file ends up on their computer. Okay, so when I run it on my computer, there's my Java program on my desktop, and there's the translated class file on my desktop. Okay. Now, if I want to run it, I run. Okay. Now, line 6 executed and created a variable with no value in it. Then line 7 created a scanner and called it in. Okay. Then line 9 prompted the user saying something, saying, give them a message to let them know that they're supposed to type something. Now, notice how the box appeared after the prompt. See how, now that's because I didn't put an ln there. See, this just said print, and it didn't put the ln, which if you put the ln there, we'll do that in a second, that would put this box on the next line. So it printed this message, and then right after it printed the message, it's asking the user to type something. Well, when it's asking the user to type something, Dr. Java creates this box. The website created a little blinking cursor. I can run this again here. See, that little blinking cursor in their interface is this box in Dr. Java's. If you compare them, see how that blinking cursor is right after the type something in. We'll change that in a minute. You'll see it looks a little different. That's because of the print, not print line. And it's not, why is it not blinking? Why is the cursor not blinking? This is a nice little, this is just a computer, it's not a Java question, it's a user interface question. Why is that cursor not blinking? Why is it blinking? Why is it not blinking?
When you're in the tab, does it just blink waiting for you to type something?
When it's in the what we call the forefront, it's the front window, then it's blinking. See, I can see it, but it's not the front window. We actually have a fancy name for that. It's called focus. Right now, this window has focus. What that means, now, here's a real interesting point. Here's a thing about computers in general. I've got two programs that are reading from my keyboard. This guy's reading from my keyboard, and this guy's reading from my keyboard. If I type something on the keyboard, who gets it?
The Dr. Java tab?
Why?
Because you're currently on that.
Yes, because see, it's the blinking one. It has what we call focus. This one, now, right now, the keyboard is attached to him. If I do this, now the keyboard is attached to him. Now watch, I'm going to type A, B, C, switch here, D, E, F, switch here, G, H, I, switch here, L, M, N, okay? Notice that whoever has focus gets the keyboard. So the keyboard is actually attached to who? What's the computer science answer to that? What is the keyboard attached to?
Your current tab.
The one that has focus.
Yes.
The word the word that programmers use is which tab has focus? Is it this tab that has focus? Is it this, like I can switch to this tab and give focus to this tab. Notice that the keyboard now is over here. Now my keyboard's over here. Now my keyboard is over here. Now my keyboard's over here. Notice that they also tend to blink the cursor that's in focus. Okay. Oh, Dr. Java did something weird. Where did my Dr. Java go? It went off to my other monitor. Okay. I want you to be able to see all these focuses at once. See if I can get them to fit in. Okay, Dr. Java has focus. He's blinking. That tab has focus. He's blinking. Dr. Java stopped blinking. Now Dr. Java's blinking. Now this guy's blinking. Some of you may have Linux computers. Now, here's an interesting fact about how computer interfaces work. How do I switch focus from here to here? How do I do it? How do I get the keyboard attached to him, not him? Oh, you're breaking up. Someone's trying to talk, but we don't hear you. How do you, pardon me?
The other one.
Say again? How do I, right now, this guy's blinking. He gets the keyboard. How do I move the keyboard over to him?
You would click back onto the Dr. Java tab.
I have to click to move focus.
I don't think there's any way, like keyboard wise, if you're not using a mouse at all, to move back to another tab, right?
Oh, there is. That's a good point. How do I move the focus without the mouse? Okay.
Alt tab.
Alt tab. See, focus. Alt tab.
Okay.
Alt tab. See, that's a great question. How can you do this with the keyboard, not the mouse? So I Alt tab to move the focus. Now, some of you may have Linux machines. Linux takes a different point of view in the world. Linux has what's called focus follows mouse. Here's what happens. On a Linux machine, when the mouse is over there, he gets focus. And when the mouse goes over there, he gets focus. Focus follows mouse. I can even Google that. You'll see that focus follows mouse is something that Linux uses. Here's somebody, how do I enable focus follows mouse in Windows 10? If you really like focus follows mouse, there's a way to turn it on in Windows 10, though Windows people don't usually like it that way. In focus follows mouse, what happens is that whatever your mouse is hovering over, that's where the keyboard goes. So I actually don't like it. It's actually not a great scheme. Because what's happening is, suppose you're typing over here and somebody actually bumps the mouse over here. All of a sudden, you're typing somewhere you didn't expect to be typing. Okay, so in Linux, focus follows mouse. On Windows, focus follows what you clicked on. Now, Windows is actually kind of subtle. This is something that changed in Windows 10 versus Windows 7. Watch something else that I can do. I'm going to bring up another browser. I have two browsers open. What I'm doing here is I'm scrolling my mouse window. He has focus. See, he's clicked on, and I'm scrolling my mouse window. I slide my mouse over here. I don't click. But the scroll window See, for your scroll bar, the scroll wheel on your mouse does it the Linux way. The scroll wheel is focus follows mouse. I don't have to click on this tab. I did not click on this tab. This tab does not have focus for the keyboard, but it has focus for the mouse, for the scroll wheel. This one has focus for the keyboard, and it also has, now it has focus for the scroll because I'm over here. If you were to go to a Windows 7 computer, it wouldn't work this way. On a Windows 7 computer, this thing is the scroll bar. And if I went over here, the one on the right would still be scrolling. When they switched from Windows 7 to Windows 10, somebody at Microsoft said, we think it's better if the scroll wheel follows the mouse. The keyboard doesn't follow the mouse, but the scroll wheel follows the mouse. So the scroll focus follows the mouse, but not the keyboard focus. When you start learning to program, you start thinking really hard about computer interfaces, and you start noticing weird little details that nobody else would notice, because as a programmer, you have to notice these things because you have to be able to program them. Okay, so Microsoft keeps actually changing the way their interface works. Different versions of Windows will make subtle choices in design issues like this. Windows is definitely, the keyboard is always going to be focus follows clicking. So the keyboard is there now. The keyboard is there now. I have to click over here to get the keyboard. I have to click over here to get the keyboard. But see how this one's blinking, but this one's scrolling. See? This one's blinking. And now, see, if I make this real short, I can make this one scroll. See? There's a little bit of scroll there. Scrolls over here. Scroll, but which one's blinking? See, the whole time, see, while this one's scrolling, if you look over on the right, you see that the one on the right's still blinking. It still has the keyboard focus, even though this one's got the mouse focus for the scroll. Now this one has the mouse focus for the scroll. Now I'm scrolling this window here, and notice that the one up here doesn't scroll. See, now this window has the scrolling. This window has scrolling. This window has scrolling. Okay. So whichever window the mouse is in, that window gets the scrolling, but it doesn't necessarily get the keyboard. It only gets the keyboard if you click on it. Now, see, the blinking's over here, and if I see, now the keyboard's in that window. Okay. So the keyboard follows where you click, but the scroll wheel follows wherever your mouse is pointing. Okay. As we go along, we're going to keep learning more and more little details about how computers work. They might seem like picky little details, but they turn out to be important ones for programmers. Okay, all right, so now back over here. Let's go back and run this program in Dr. Java. There's our first input. I'll make it something easier to read. Okay, so right now, remember, we're in line. Okay, we were in line 10. That was the first prompt, the first box, the first time we called scanner. Then we read in the hello class, printed out the hello class there. Then we prompt the user again. There's the second prompt. Now we're waiting on line 14. So now we're at line 14. Okay. And I type something else down here. Now I had to shift the focus down to here. Hit enter. Okay. Now let me make a change in this program. Let me run it one more time. Okay, the box is right after type something. The box is right after type something else. Let me change this print to a print line. Compile it. Run it. See where the box went? Because print line said end the line with go back to the beginning of the next line. So now the prompt was actually on the next line. You know, it's a minor thing, but some people think that what you type should be right after the prompt. Some people like it when it's below the prompt. Now what I type is below the prompt, but notice that the next one, what I type is next to the prompt. Okay, some people like it one way, some people like it next way. See, this one printed the prompt, but didn't put a new line after it. So the input is on the same line. What the user types is on the same line as what the program printed out. Since there wasn't an ln here, what the program typed out is on the same line as what the user types in the prompt. And if I go to this other website, it works the same way. Okay, watch over here. Let me rerun theirs. Okay, type something. See, what I type is on the same line as what the computer printed out. The computer said type something, it printed type something, and my input's on the same line. Then it said type something else. It said type something else. What I type is on the same line. What if I change this to an ln? Whoops. Okay. Now type something, then new line. So what's it going to look like? Now run it. Notice type something, then what the user types starts back here on the next line. It's not right after the prompt. It's right. Now, some people like it one way, some people like it the other way. So I type my input there. Now, here, the input's right next to the prompt because I left it print and I didn't change it to print line. And if I want them both to act the same way, I can put a print line there. Compile and run it. Okay. See, the prompt is up here, but the input is down here. And then the prompt is up here, but the input's down here. Okay, so that's a minor thing, but notice that the program acts differently. If I do a print line, it looks a little bit differently than if I do a print. Okay. All right. Now let's do something else with the scanner. What about reading numbers? Okay. Right now we're reading whole sentences from the scanner. The scanner can read in numbers too. So this would be here's what it would look like. Instead of saying type something, let me say type an integer. Okay. All right. Now, and I'm going to say here, you said, okay, then I'm going to say type a decimal number. Okay. All right. Now I'm going to compile this and run it. I'm going to type my integer. And you said 23. I'm going to type my decimal number. Okay. Now, those were not integers and decimal numbers. Those were strings. But if I want, I can actually type in, like, I can actually get the scanner to read numbers. And what I do is I change this thing from next line to next int. Whoops. Instead of saying next line, if I say next int, but now I have to change this to an integer. So I say int a, and I get next int. And here, if I want a double, a decimal number, I say next double. And then here, instead of using the string variable, I have to use a double variable. Okay. And to prove that they're really numbers, I could do this. I could do arithmetic on them. I would not have been able to do arithmetic on the strings that people type in. This is a little bit tricky. We're going to see. Let's see what I do wrong here. Oh, I forgot to change it to a, and here you said x. Okay. Now, watch something here. Suppose I type XYZ. My program blew up because I told it to read an int, and this is a weird thing. Scanner is supposed to read an int, and I typed XYZ, and the program just crashed. Okay, let me run it again. Type an integer, so type an integer. Okay. Type a decimal number. Okay, and then 23 plus 12.4 is 35. See, it really read numbers now. It didn't read strings, it read numbers. We run out of time. Let me just show you a little picture here. Here's what, this is a little picture of another book. Here's what you can do in a scanner. You can ask for next line, which is what we've been using. You can ask for an integer or a double, and you can ask for, instead of a whole line, we'll do a little bit more with this on next week. You can ask for a word. Next asks for the next word. Next line grabs the whole line. Essentially, this would be like next sentence versus next word. And that's a subtle difference between those two. So these are the four things you could do with a scanner. You can ask for a whole sentence. You can ask for just an int, just a double, or you can ask for a word. And if you ask for an int and somebody types in a word, your program blows up. If you ask for a double and somebody types in a word like XYZ, your program blows up. Okay, so we'll play a little bit more with scanners beginning of next week. We'll learn a little bit. We'll learn a little bit more about this next int, and next double, because they're a little bit tricky to use. That's where scanner gets a little bit hard. There's some confusion about the right way to use next int and next double. Okay, but we ran out of time, so we'll stop there. And anybody got any question? Anybody got a last minute question?
Just a quick question now. So you see how you did on the very last system that print line A plus X, because you wanted to know what type you were using. Mm-hmm. Is there another command in Java that says, hey, display this type? Like, is this a string? Is this an integer? Is this a double?
No, okay. Yeah, it won't tell you what kind. It won't tell you what kind of variable something is. Yeah. Okay. So you have to read your code. So you have to read your code to say A was an int, X was a double.
Okay.
Okay. There actually is a way to ask Java what type something is, and maybe we'll probably never see it in this course because it's kind of complicated. But actually, the answer to your question is yes, you can ask Java what type of variable is, but it's kind of complicated thing because it's not very often, it's kind of rarely done. Yeah, but if you send me an email, I can probably show you that there is a funny way to ask Java what a variable is. It works, but I don't know if it works with all variables. I don't remember if it even works with every variable. Okay, so it's not something you do very often.
Okay.
What about any other last minute questions? Anybody got any last minute questions about scanner or what we talked about, or homework? Okay, I'll go ahead and I'll stop the sharing, and I'll go ahead and end the meeting for all. And let's see, remember, we don't have class on Monday, so we'll meet again a week from today. And if you have questions in the meantime, please just send me an email or so. Okay, see you next week. Have a nice weekend. Bye.